Hello everyone. So today we will talk about what are the three effects of capacitance. Before starting this, I have already uploaded a video on introduction to capacitors and what are the parameters related to capacitance, what is the practical model of capacitance, what is the frequency impedance curve related to capacitance. So please go and watch that video. Now let's start this topic, the three effects of capacitance. Before that, let's start with a brief introduction. So as you know, capacitance is a passive element that stores charge in electric field. So we all know this. The second, I will call it as a I is equal to C dV by dt. The second is the capacitor registers the change in voltage instantaneously. It means when you see this equation I equal to C dV by dt, saying that the dt, if dt goes to 0 instantaneously, right, it means this term will tends to infinity. Okay, it means you have to provide infinite currents for the instantaneous change in voltage, which is not possible. That is why we say capacitor resists the change in voltage instantaneously. Okay, so we'll try to use these two basics, okay, and try to see what are the three effects of capacitance. The first is it resists the change in voltage and store charge according to formula Q is equal to CV. So let's see by example. Here I have a voltage and time square wave. Okay, you can see the square wave inputs, and I am measuring a voltage across capacitance. So you can see whenever the voltage is changing instantaneously, right? So your capacitor, right? Your capacitor is resisting that change in voltage. Here you can see, right? You see this. Here also you can see this. The gradual, right? So it is resisting that steep change in voltage. It is resisting that. So you can use this in different circuits or applications. Okay, this behavior of capacitors. The second is frequency filtering. So this is my low frequency wave. Okay, you can see that low frequency wave. And when I change the frequency or when I increase the frequency on my oscilloscope, you can see that gradually the amplitude decreases. It means the capacitors allow AC to pass. Okay, okay. It means the high frequency, but it block DC. Okay, the low frequency. So you can see this. Okay. The third is it allow the phase change between voltage and current. So you can see this, right? There is a voltage and current. Okay, they are on the same phase. Okay, by this you can see this. But here, okay, you can, if I draw a line here, right, you can see that the voltage and current there is some 90-degree phase shift. Okay, and this basics behavior, it is used in different application. Okay, like in AC induction motor it is used, right? The capacitors, okay, start capacitors, they are used, or in some power factor corrections also they are used. Okay, so these are all the behaviors that capacitor exhibits, and they are used in multiple applications. Thank you all.